What if the encounters between Homo sapiens and Neanderthals in the Levant were not isolated events, but part of a long-term, repeating process shaped by ecology, geography, and time? Genetic evidence confirms that modern non-African humans carry Neanderthal-derived DNA. Archaeology also shows that both populations occupied the Levant during different intervals of the late Pleistocene. But these interactions are often imagined as discrete episodes. This model asks a different question. What if contact was recurrent, probabilistic, and cumulative? The Levant was a narrow biogeographic corridor between Africa and Eurasia. Bounded by the Mediterranean, deserts, and upland terrain, it constrained movement and repeatedly funneled populations through the same landscapes. This geography created spatial bottlenecks, restricted dispersal routes, and recurrent zones of convergence. In such a system, complete separation between populations would have been difficult to maintain over long periods. The uplands of Mount Carmel and the Galilee offered vertical ecological zonation. Temperature, vegetation, and water availability shifted with elevation. This allowed short-range seasonal movement without requiring major long-distance migration. Resources in the Levant changed seasonally. During winter and early spring, scarcity may have intensified territoriality and conflict. During summer and autumn, relative abundance likely increased mobility and reduced direct competition. Gazelle, aurochs, wild equids, and ibex did not remain static. Their seasonal aggregation and movement corridors structured hunting opportunities. As prey moved across the landscape, human groups may have repeatedly converged on the same resource zones. The record suggests multiple phases. Early Homo sapiens dispersals around 120 to 90,000 years ago, Neanderthal reoccupation between 90 and 60,000 years ago, and sustained Homo sapiens expansion from roughly 60 to 50,000 years ago. Rather than isolated phases, these may reflect fluctuating overlap intensity within a continuous interaction field. The two populations were likely not demographically equal. Homo sapiens may have formed larger and more connected populations. Neanderthal groups were likely smaller and more fragmented. This asymmetry could make gene flow and long-term outcomes uneven. Interaction may have taken many forms: seasonal avoidance, episodic conflict, neutral co-presence, resource partitioning, convergence at bottlenecks, de-escalation during abundance, and, in rare cases, genetic exchange. In this framework, contact is modeled as a stochastic process. Its probability depends on seasonality, resource distribution, demographic structure, and landscape constraints. Most encounters may have left no trace. Only a minority produced behavioral or genetic consequences. Over long timescales, repeated low-probability encounters may accumulate. Introgression, behavioral adaptation, and shifts in population structure do not require constant contact. They may emerge from many rare events distributed across generations. This system may also display threshold behavior. When the rate of interaction rises above a critical level, the overall dynamics may shift. Gene flow may accelerate, conflict may decline, stable patterns of contact may emerge. The implications are significant. Neanderthal introgression may be better understood as a cumulative process rather than a single event. The final outcome may not have been abrupt replacement, but asymmetric absorption shaped by demography, ecology, and repeated contact. This model makes testable predictions. Interaction signals should cluster in ecological bottlenecks, site use may show seasonal patterning, contact evidence may be stronger in transition zones, and introgressed alleles may be distributed unevenly across populations. The Levant may be best understood not as a static boundary nor as a single dispersal route, but as a temporally extended probabilistic field of interaction, where ecology, movement, and repeated encounters shape the evolutionary relationship between Homo sapiens and Neanderthals. A systems-level perspective on contact, introgression, and cumulative evolutionary change.